All right, let's do some homework problems. Everyone loves a good homework assignment. Am I right? So we're going to start with number 44, I believe. No. We've already done this one. We're going to start with number 46. Which wants us to find a formula for this function. Okay, so we look at 46, and first we have to find the toolkit function. So it looks like an upside down V. The toolkit is going to be the absolute value of x, right? Absolute value of x normally looks like that. This is just that upside down. So that upside down is going to be reflected about the x-axis. What else is happening? It's also getting moved right 2 and up 3, right? The tip of the V, the vertex, is normally at the origin. Well, now it's right 2 and up 3. We're going to say it's right 2 and up 3. And again, it's not going to matter here, but it's a good idea to get used to this order of this rule of thumb. Horizontal shifts first, vertical shifts last, and everything else in the middle. So if we do that, let's just do things one at a time. Right 2 means subtract 2 on the inside. Reflected about the x-axis, that's a vertical change. The negative goes on the outside. And up 3 means a plus 3 on the outside. And this should be our answer. Let's check our work. We have negative absolute value of x minus 2 plus 3. Are these the same functions? Oh gosh darn it. It's refreshing again. Are these the same functions? They look pretty similar. If you check them point by point, they will be the same. Okay. And as a quick side note, I didn't mention earlier why the order matters. But notice if we did these in a different order. What if I did right 2, up 3, and then reflect? Well, right 2 would still be x minus 2 like this. Up 3. Well, technically, if we reflect now, you put a negative in front of everything. But we only want a negative on the inside. So actually, I don't really want to get into it right now. But if you're curious, I'd love to talk about it. But I don't want to take all the time up in this video. But the idea is that, right, if you move it up and then reflect it, that's like a downward change. Whereas if you reflect it and then move it up, it's still an upwards change. Let's do the next one, 70 and then 80. Look at number 70 here. Describe how the formula is a transformation of a toolkit function and then graph both of them. I think I already did that one. So let's change that as well. Let's do 72. All right, so k of x equals negative 3 times the square root of x minus 1. Horizontal shifts first. There are none. Vertical shifts last. That's going to be down 1. Now there's two other things. A negative on the outside is a vertical change, a reflection about the x-axis. There's also a 3 on the outside. That's a vertical stretch. So these are all the transformations that are being done. But we also want to sketch. We'll use Desmos to help us sketch. But we are going to copy our answers here. So you can use, wait, this doesn't give me very much room. There we go. The toolkit function, square root of x, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. This is what our toolkit function looks like. Oh, that kind of looked decent. And so what do these transformations look like? Well, you can do this by hand, but I'm not forcing you to. So let's just use Desmos instead. We have -3 square root of x minus 1. So now the start of this function is at this point right here, 0, -1. And then I didn't give myself enough room here because it goes down pretty far, right? So what's another point on here? Another point is 1, -4, which already doesn't fit. Here, hold on, watch this. I am powerful. Whoa, look at that. 1, -4 is right here. And then what are some other points? Um, 2, 4, 7 is another point over here. 4, 5, 6, 7. And so this one's really stretched. And it's reflected and it's moved down. So that's the toolkit function up here. And this is the transformed one down here. All right, and that is problem number 72. Let's do 80. And if 80 is also one I've already done, I'm going to lose it, okay? You're going to see me go wild. Go to the book, problem number 80. All right, we haven't done this one. Use the graph to sketch the transformations. Here's the graph of the original function. This is a cosine graph, which we haven't covered yet, but that's okay. Question is, what happens if we look at this function with a +1 on the inside? I really wish I could just copy this image and paste it, but we're going to copy it by hand into our notes. So just got rid of this. Let's get it back. Going to copy it by hand. Just like so. It starts at 0, 5. And then it goes down to 2, 0. And it's an even function, right? It's symmetric on the left and the right. And then it goes to 4, -5. This is 5 up here. 1, 2, 3, 4. -5 is down here. And it's the same on the left as on the right. And then it actually just does the same kind of oscillating. Just like so. So this function, we're just copying down the original graph. We're copying down the original graph so we can compare. It does this forever. This is y equals f of x. But for problem number 80, that wants us to look at g. G is f of x plus 1. What transformation is being applied here? Well, +1 on the right, or on the inside, means left 1. So we move all of these points to the left 1. Every single point here gets moved 1 unit to the left. That's going to be our new graph G. All we do, pretend these are all going through the dots. That's all it wants us to do for problem number 80. The red graph is just the white graph shifted 1 unit to the left, because +1 on the inside is a horizontal shift. And you can do that for all of these ones. 78, you move the whole graph down 2 units. 79, you reflect each point about the x-axis. 81, you move the whole graph right 2 units. All right, let me know if you have any questions, and bye-bye.